Hey everyone! Welcome back to our C# tutorial series. I hope you're ready for today's lesson, because we're going to dive deep into one of the most fundamental and exciting concepts in programming, object-oriented programming, or OOP for short. If you've ever wondered how large-scale applications are built, or how developers keep their code organized, reusable, and easy to maintain, OOP is the answer. It's the foundation of modern software development, and mastering these concepts will take your C# skills to the next level. Today, we'll cover the 4 key pillars of OOP. Encapsulation, inheritance, polymorphism, abstraction. By the end of this video, you'll not only understand what these concepts mean, but you'll also see how to apply them in C# to create robust, reusable code. So, grab your favorite beverage, get comfortable, and let's dive into the world of object-oriented programming in C#. Before we jump into code, let's first talk about what object-oriented programming, OOP, actually is. In its simplest form, OOP is a programming paradigm centered around objects, which represent real-world things. Think of objects like cars, people, or bank accounts. Each object has properties, like a car's color or a person's age, and behaviors, like driving a car or withdrawing money from a bank account. By breaking down your program into objects, you can organize your code in a way that's easy to understand, maintain, and extend. Instead of writing one giant chunk of code, you create smaller, self-contained objects that handle specific tasks. Now, let's break down the 4 key principles of OOP in C#. Encapsulation is the concept of bundling data and methods that operate on that data into a single unit, known as a class. It also involves restricting direct access to some of an object's components, which is known as data hiding. Think of it like a black box. You know what the object does, but you don't necessarily need to know how it works under the hood. This helps keep your code clean and prevents unwanted interference from external code. Let's look at a simple example of encapsulation in C#. In this example, the balance field is private, meaning it's hidden from outside the class. The deposit and get balance methods allow controlled access to that data. This way, you ensure that balance can't be modified directly from outside the class, maintaining its integrity. Inheritance allows you to create a new class that is based on an existing class. The new class, called a derived class, inherits all the functionality of the parent class but can also add its own unique features. This is great for code reuse. You don't have to write the same code over and over again for similar objects. For example, let's say you're building a program that manages different types of accounts. Instead of writing separate code for each type of account, you can create a base class called bank account, and then extend that class for savings account and checking account. Here's what inheritance looks like in C#. In this example, the savings account class inherits from bank account. It gets the deposit and get balance methods for free, but it also has its own add interest method to add interest to the balance. Inheritance is one of the most powerful tools in OOP because it lets you build on existing code without duplicating it. Next up is polymorphism. The word polymorphism comes from Greek, meaning many forms. In OOP, polymorphism allows you to treat objects of different classes in the same way, even if they behave differently under the hood. There are 2 types of polymorphism in C#. Compile-time polymorphism, also known as method overloading. Runtime polymorphism, also known as method overriding. Let's take a look at method overriding with an example. In this example, even though my account is of type bank account, the program calls the showAccountType method from savings account because it overrides the method in the base class. This is polymorphism at work. It allows objects of different types to be treated as if they were instances of a common base class while still behaving in their own unique way. Finally, let's talk about abstraction. Abstraction allows you to focus on what an object does, rather than how it does it. In C#, you can achieve abstraction through abstract classes and interfaces. An abstract class is a class that cannot be instantiated on its own and is meant to be a blueprint for other classes. It can have both fully implemented methods and methods that must be implemented by derived classes. Here's an example of abstraction. In this example, animal is an abstract class with an abstract method makeSound. Each subclass, like dog, must implement the makeSound method, but it can also inherit regular methods like sleep. Abstraction is a great way to create a flexible blueprint that can be adapted in different ways. So, how do these four pillars, encapsulation, inheritance, polymorphism, and abstraction, come together in a real-world application? Well, let's say you're building a banking system. You'd use encapsulation to hide sensitive data like account balances, inheritance to create different types of accounts, such as checking and savings accounts, polymorphism to allow these different accounts to have customized behavior while still sharing a common interface, abstraction to define general account behaviors, leaving the specific implementations to the derived classes. By using these principles, you'll write code that is easier to understand, maintain, and extend. It's challenge time. Now that you've learned about the four pillars of OOP, it's time to apply what you've learned. Here's your challenge. Build a console application that models a simple library system. Requirements. Create an item class that contains basic properties like title and ID. Create two derived classes, book and magazine. Implement polymorphism by overriding a method to display the type of item, book or magazine. Use encapsulation to ensure that ID cannot be directly modified. Implement abstraction using an abstract class or interface that defines common behaviors for all library items. Demonstrate inheritance by sharing common functionality between book and magazine. Bonus. Add a method that simulates lending an item to a user, which updates the availability status. Once you've completed the challenge, feel free to share your solution in the comments below. I can't wait to see how you approach this problem. And that wraps up today's deep dive into object-oriented programming in C#. We've covered encapsulation, protecting data and keeping it safe from unwanted access. Inheritance, reusing code efficiently across different classes. Polymorphism, giving objects the flexibility to behave differently, even when treated the same way. Abstraction, simplifying complex systems by focusing on the what rather than the how. Mastering OOP is crucial for writing clean, maintainable, and scalable code. Whether you're building small apps or large-scale systems, these concepts will help you stay organized and productive. In the next video, we'll explore even more advanced C# features, such as delegates and events, which will further expand your ability to write dynamic and responsive applications. As always, if you found this video helpful, give it a thumbs up, subscribe to the channel, and don't forget to hit the notification bell so you never miss an update. If you have any questions or want to share your thoughts on today's lesson, drop a comment below. Thanks so much for watching, and I'll see you in the next video.